Okay, so most of the types of problems in the practice problems, when they ask you to find a zero for a polynomial, they kind of give you a starting point, but not for all of them. So I'm going to take out of the review, this will be number 86. So it says g of x is equal to x cubed minus 7x squared plus 36. And the directions specifically, I'm going to copy and paste these directions in. Write the polynomial as the product of linear factors and list all the zeros of the function. So the product of linear factors is basically just write it in factored form and then list all the zeros. So this is, because it's not a quadratic, we can't just factor it like we would normal. We have to factor it by using synthetic division. And when you don't have a starting point, when it doesn't tell you where to start in order to factor, you basically have to do guess and check. And we base those numbers based off of the choices for the rational zero theorem. So the first thing that I always do is use the rational zero theorem so that I know where I should start guessing. So we have the rational zero theorem, where you have plus or minus p over q, and these are factors of p and q. So p is the constant, and then q is the number that's in front of the highest term. So p in this case is 36, and q is going to be 1. So the factors of these numbers are numbers that divide evenly into them. So our factors of 36, if we just start with, I just usually just start counting. So 1 goes into it, 2, 3, 4, 6, 8, 9. And you can just use a calculator, just keep dividing basically until you go all the way through. I think that's 12. Let's see. And they usually come in pairs, which is kind of nice how it out. So like 4 times 9 is 36. 3 times 12 is 36. So I need 2 times 18. That will get me to 36. And then 1 times 36. So you're listing all of the numbers that divide into that value for the rational zero theorem. And then since it's plus or minus p over q, q in this case is just 1. So you're just going to be dividing all of these numbers of 1. So our possible zeros are either the positive or the negative version of each of these numbers. So it can be a positive or negative, which is a lot of numbers to check, but at least it gives you a starting point, because without at least knowing what numbers to check, you basically have an infinite number of choices. But here, at least I know, okay, these are the numbers I should be checking. So once I've decided what my possible zeros are, then I'm going to set up my synthetic division and just start going through it to try to find a zero. So we have an x cubed and x squared. We don't have an x term, so when I set up the synthetic division, I'm going to have to put a 0 there. So I'm going to have my 1, -7, 0, and then 36. And then I set up my synthetic division than the way the book does, and that's because of the way that I'm testing my possible zeros. It just makes it a lot easier for me if I use it in table form versus making it sort of look like division like they do, because then I don't have to rewrite anything. So I usually just start with 1 so I'm going to pick 1 from the possible zeros, and then I just go through my synthetic division and hope that I come out to something that will be 0 at the end. So a lot of this, when I'm checking possible zeros, I don't usually write down any of the math. I just write the final answer of the multiplication and the adding, because I can just do that on a calculator. So you're multiplying 1 times 1, and then you're taking that answer and minus 7. So you can just do 1 times 1 minus 7 on your calculator. And so then you get negative 6. So then I have 1 times negative 6 and then plus 0, because that's my next number. And you can just do that on a calculator, or you can do it in your head, but that comes out to negative 6. And then 1 times negative 6 plus 36, and that comes out to 30. So that's not a 0, so that means negative 1 is not a 0. Or I mean, 1 is not a 0. That's the first. So that doesn't work, so then I want to move on. So I usually then next try negative 1, because multiplying by 1 and negative 1 are the easiest numbers to check. So I just write it as a line, so that way I don't have to rewrite my synthetic division. I just have to remember that all of these numbers are being multiplied by and added to the black numbers. And so I have this time negative 1 times 1 and then minus 7. So that's going to give me negative 8. Then negative 1 times negative 8 plus 0. So that gives me 8. Then negative 1 times 8 is negative 8 plus 36. And for some reason, that in my head does not seem easy. So negative 8 plus 36. I pulled my calculator out for that one. They gave me 28. Okay. So that's not even remotely close to 0. And you can kind of see that if I need something to cancel out with that 36 in the, I need to start getting some bigger numbers. So especially with that 0, because that 0 is not going to add anything. So my goal in this third column is I'm going to want something that's maybe half of 36 that I can multiply it by 2 or something like that. So I think the next numbers that I should try are probably 2 and negative 2. So I'm just going to extend my line here. And so I always just try positive number first. So I'm going to do 2 times 1 minus 7. And I'm going to just straight do that on my calculator just to make sure I'm not messing anything up. So that comes out to a negative 5. Then you have that 2 times negative 5, then plus 0. So that gives us negative 10. Then 2 times negative 10 plus 36. And this gives us 16. So that's enough smaller and closer to 0. And so what I do when I'm trying to figure out, and we're basically guessing and checking here. And these values, these output values, the very last number, not only is it just like that's also a y value if you want to think about it. So at 1, we're all the way up at like 30. And at negative 1, we're like down here. So you can think of like, okay, if I was graphing, I'm looking something like that. But then I basically became half the size right there at 2 because my output was 16. So I'm looking at where this is going. I think if I pick a number like 3 or 4, I'm going to get closer to 0 because if I kind of follow the trend here, it looks like it's going to keep going down. So that's how I sort of decide what numbers I'm going to pick when I'm checking these possible zeros. So I'm going to try 3 next. So I'm going to do 3 times 1, which is 3, then minus 7. So that gives me negative 4. Then 3 times negative 4 plus 0, so that's negative 12. And then 3 times negative 12 plus 36. That gives me 0. So now I've found one of my zeros. So one of them is going to be 3. So I know that here at 3, I'm going to be down here. So it's probably going to go down like that. So you keep guessing and checking until you find something. And that 3, when we write it in factored form, would be x minus 3. And then what's going across our synthetic division is the coefficient. So we started with something that was x cubed. We've now removed an x, so now it's going to be an x squared. So that's going to be 1x squared minus 4x minus 12. So just as a reminder of what we're doing here, the question says to write the polynomial as a product of linear factors and then list all the zeros. So we have found 1 0, but we're not done. It's x cubed, so there should be 3 zeros. So we have 2 more. And now the next part is we need to deal with the this x squared minus 4x minus 12. So because that's a quadratic, that's usually where I go to try to factor or use the quadratic formula to find the remaining zeros. So I would just do the synthetic division until I get to something quadratic where I can use a different method and I don't have to keep guessing and checking. If you have something that's a higher exponent, like x to the 4th, you'd have to do the synthetic division to find 2 zeros before you get to a quadratic. And then once you get to that quadratic, you can factor or quadratic formula. This quadratic here factors. So I can go straight there. So I'm looking for 2 numbers that multiply to negative 12 and to negative 4. So that's going to be negative 6 and positive 2. So that'll give you negative 12, and negative 6 plus 2 is negative 4. And if you're wondering how fast I was able to do that, if you do enough factoring problems, you get to a point where you basically have the most common types memorized and you don't even need to do any thinking. You just look at it and know what it factors to. So that's something that comes with practice. So I do that. So now I have done the part where it said write as a product of linear factors. So that's what I have here. These are a product of linear factors, and then it says to find the zeros. So we already know one of the zeros. The x minus 3 gives us a 0 of 3. And you can find the other zeros. You set each equation equal, or each factor equal to 0 and solve. And the thing that I remember is it's basically the number but at the opposite sign. So we get x equals 6 and x equals negative 2. So we have 3 zeros here. And you notice that these are all 3 of those numbers are basically on our list of possible zeros. And then we also have our product of linear factors, which we needed to basically help us find those other zeros. Yeah, so that's basically what you had to do on the assignment. We had something that was x to the 4th. So you had more steps that you had to do to get to that point. But that's why we have rules like the rational zero theorem. And Descartes' rule of signs can help you know whether you should be trying positive numbers or negative numbers. So they kind of just help narrow down the possibilities when you're doing the guessing and checking. Although these days we have a calculator, or you have like a graphing calculator, which makes it much easier than having to, if you can imagine trying to graph these things before you had calculators, like it would be really difficult. Okay, so this is 4.1, number 18. And the directions say find all vertical and horizontal asymptotes of the graph of the function, and we are given f of x equals 2x squared over x plus 1. So I always start with the vertical asymptote because that is just the easiest thing to find, and that's where you set your denominator equal to 0. So our denominator is x plus 1. I'm going to abbreviate this VA for vertical asymptote. So you set your denominator equal to 1 and you just solve for x. So if it's linear like this, it's pretty simple. And so your vertical asymptote is at x equals negative 1. The horizontal asymptote is where things get a little more complicated, because in this case, the top is a quadratic, which is degree 2, and the bottom is a linear, which is degree 1. So when the top has a degree that's larger than the bottom, that's telling us that we have a slant asymptote. So there is no horizontal asymptote. So you would say like there is no horizontal asymptote. Now I'm going to go through and show how to find the slant asymptote because that's good practice. So the slant asymptote is found by doing long division, or you can do synthetic division. If the denominator is x plus or minus a number, you can use synthetic division. If it's anything else, like if it has a number in front of the x on the bottom, like it's 2x plus 1, or if it's like a quadratic and it's an x squared in the bottom, you can't do synthetic division and you have to do long division. So I'm going to just do it with long division, even though in this case we can use synthetic division, just because it's good to get more practice with the long division so that you can, if you have another situation where you have to use it, you at least have a refresher on the steps. So we're going to slant asymptote by taking 2x squared and we're dividing it by x plus 1. Actually, I'm going to have to give myself some more room here. And I like to add in zeros for all of the missing terms because I don't know whether I'm going to need them or not. So I'm going to just add 0x plus 0. So when we do long division, we're always taking the first term divided by the first term for each thing there. And so I like to do side work here so that you can, I usually do long division in my head these days, but you guys are not at that point yet. So I like to do some side work. So we're basically taking that 2x squared, dividing it by x. And so you're just simplifying. So that gives us a 2x because one of the x canceled. And so I write that on top above the 2x squared. And then I take that 2x and I'm going to multiply it by a denominator, x plus 1. I'm going to distribute. So I have 2x times x, which gives me my 2x squared. And then 2x times 1, so that is 2x. And then I'm going to write that underneath. Then we subtract. So there's this little rhyme. Draw the line, change the signs, then combine. So basically, anything that's a plus is now a minus, so I usually circle it to help me remember that. So that I remembered I changed the sign. And then I basically add them together. So I have a 2x squared minus 2x squared, so that's 0. They cancel. And then a 0x minus 2x, so I get a minus 2x. And then I'm going to drop down my plus 0 because I'm going to need it. Now we're going to repeat the process, and this time I'm going to use the minus 2x instead of the 2x squared. So I'm going to have minus 2x divided by x. So the x's cancel and we're left with negative 2. So I'm going to write that on top there. So we have negative 2. And then I take that negative 2 and I multiply it by x plus 1. So negative 2 times x gives me negative 2x. And then negative 2 times 1 is minus 2. So I'm going to write that underneath. Negative 2x minus 2. I draw my line. I change the sign. So now all the negatives become positives. And then I combine. So negative 2x plus 2x is 0. 0 plus 2 is 2. So that 2 is going to give me a remainder, because if I try to go further, I'm going to get 2 over x and it doesn't do anything. It doesn't reduce. So that tells us when we have a remainder. When we're finding the slant asymptote, we don't care about the remainder. We only care about what is on the top here. So that is our slant asymptote. So we're going to get x equals, or y equals, 2x minus 2 as our slant asymptote. And for this particular problem, you can repeat this with synthetic division and you'll get the same thing. So just for good practice, I'll do that as well, just to show you that you get the same answer. So we have 2 0, and 0. So you see I still use those placeholders. And then we have x plus 1. We're going to use minus 1 in our synthetic division. And then I have a 2. So I have negative 1 times 2, so that's negative 2. Negative 2 plus 0 gives me negative 2. Negative 1 times negative 2 is a positive 2. 2 plus 0 is 2. So again, that last 2 is a remainder. So for the slant asymptote, all we care about is this stuff here. So we got y equals, and this also gives us 2x minus 2. So you get the same answer both ways. I just did the long division because sometimes to find slant asymptotes you can't use synthetic division. So it's good to show you both ways so you know how to do it. But that's, in this case, you would say there's no horizontal asymptote, but there is a slant asymptote. For any questions, did that help?
That did help. As far as the answer, you would just be putting that there's a vertical asymptote and list that there was a slant, or you would just say that there's not a horizontal, since it was just the vertical and the horizontal.
I like to be very complete, and so I would personally say vertical asymptote is x equals negative 1. There's no horizontal asymptote, but there is a slant asymptote, y equals 2x minus 2. Just to make sure that it's all out there, because the way that I was taught this is that whenever a question asks for horizontal asymptote, you give the slant asymptote if there is one. Our particular textbook doesn't necessarily operate that way, but each textbook has different conventions for these things, and I think it's better to give more information than to not have enough.